Hello everybody. In today's video, I'm going to be showing you how to calculate the standard deviation. Now the standard deviation is basically a measure of spread. It tells you or it describes how spread out certain data is. So in this example, the number of hours a sample of students spend doing homework per week is given below. And you can see that we have 8 different values right there. So before you can calculate the standard deviation, you always want to calculate the mean, because the mean and the standard deviation go hand in hand. Now a symbol for the mean is an X with a bar on the top of it, and you pronounce it X bar. So remember, to find the mean, you would add up all these values. So if I add all these up, you're going to get a total of 56. And there are 8 values, so divide by 8. So therefore the mean is going to be 7. So once I've figured out the mean, I'm now ready to figure out the standard deviation. Now the standard deviation has a formula that looks a little complicated, but I'm going to take you through it and show you that it's not that bad. So the formula looks like this. First of all, S represents the sample standard deviation. And then to calculate it, you're going to take the square root of, and this is the sigma sign, and then we'll say xi minus the mean, x bar, all squared, all over n minus 1. Now that looks like a complicated formula. What it basically means is this. The sigma right there means the sum of. So what you're going to do is you're going to add up all these values. Now these values are all the individual values minus the mean, all squared. So let's go ahead and do that. So we're going to make a table here for xi minus x bar all squared. So basically what we do is we take each of these values. So let's look at the first value, which is 5, and then I minus the mean, and then I square it. And so 5 minus 7, that will give me -2. -2 squared will give me 4. And then I do it for all the other values. So I'm going to do 9 minus the mean, all squared. So 9 minus 7, that's 2. 2 squared, that gives me 4. And then I just keep going. Next one is 10. So 10 minus the 7, remember we're always subtracting the mean every single time and then squaring. 10 minus 7 is 3, square that, you get 9. Next one is 8. 8 minus 7, all squared. That's 1 squared, so that gives you 1. Then you're going to have 7 minus 7 squared. That'll give you 0. 5 minus 7 squared. That'll give you 4. Let's see if I can squeeze it in. 8 minus 7 squared is going to give you 1. And then finally, didn't quite get it in there in time. Oops, 4 minus 7 squared, that'll be -3, all squared will give you 9. Okay, all right, note to self, for next time I need to make more space. So once you've done all that, the sigma sign just means you're going to add all those up. So when we do the sigma, that means we're adding up. So if I add up 4 plus 9 plus 1 plus 0 plus 4 plus 1 plus 9, I will get a value of 32. Okay. All right, so again, we've done the top part. Sigma means to add up. And what are we adding up? All the individual values minus the mean, all squared. So let's go ahead and plug these numbers in. So now we're going to have the square root of the sum of all those, which I know is 32. And then I'm going to divide by n minus 1. Now n is the sample size. So in this case, the sample size is 8. So I'm going to be doing 8 minus 1. Now, this is the standard deviation for a sample. There is another formula for the standard deviation for the population where you'll just be dividing by the sample size. I would suggest you always use the one that I'm showing you here, because more often than not, you're not going to know all the values in an entire population. All right, so I'm going to have the square root of 32 all over 7. So this will be where you need a calculator. So I've got my calculator right here. 32 divided by 7 gives me that. And then I'm going to take the square root of it. So I get 2.14 if I round it. I would just go to like maybe 2 decimal places. So 2.14. So my standard deviation is 2.14. Okay, so that's all well and good now that I've calculated the standard deviation, but I want to interpret it. All right, I want to know what this actually means. So here's how you would interpret it in context here. So remember, we're talking about the number of hours students spent doing homework in a given week. So the way you would interpret it is like this: the amount of time students spend doing homework per week, and this is the important part, it typically varies. Remember, standard deviation is talking about the spread. So we're trying to see what the variation is, how much something varies. So the amount of time students spent doing homework per week typically varies. All right, what does it vary from? Well, it varies from the mean. All right, remember the mean was 7 by about 2.14 hours. Let me just say that again. So when you're interpreting the standard deviation, we're talking about how that relates to the mean spread, like how much spread out it is. So again, the amount of time students spend doing homework per week, it typically varies from the mean by about 2.14 hours. All right, so the last thing I want to ask is, within how many standard deviations of the mean do all the values fall? So what we're going to do is we're going to create a number line. And remember, the mean was 7. So what we're going to do is we're going to add and subtract the standard deviation. So remember, the standard deviation was 2.14. So if I add that to 7, I get 9.14. And then if I add it again, I get 11.28. So I've only just done that twice for the moment. Now I'm also going to subtract it. So 7 minus 2.14, that will give me 4.86. Then I'm going to minus 2.14 again. Try that one more time. 4.86 minus 2.14, that give me 2.72. Now I could keep on going, but the question was, within how many standard deviations of the mean do all the values fall? So remember, here's the mean, and my values, which I had all the way up here, let's just bring those down again. Okay, were 4, 9, 10, 8, 7, 5, 8, and 4. Okay, so if you look at all that data, the lowest value I have is 4, and the highest value I have is 10. So 10 would be roughly around here. 4 would be roughly, around here. But I got to do it equal numbers on each side. So this would be one standard deviation. Doesn't quite include all of them. This would be 2 standard deviations. So that does include all of them. So the answer, therefore, would be 2 standard deviations. So all the values fall within 2 standard deviations. Okay, so remember, if the data was really, really spread out, maybe this number might be 3 or 4, but in this case, it's 2 standard deviations. Okay, so you can go into a lot of detail later on if you ever take probability and statistics or AP statistics and learn more about what the standard deviation does with respect to the mean. But for today's lesson, it's just all about getting the basics. So focus on how to calculate it using this formula, and then more importantly, know how to analyze it and how to calculate how many standard deviations each of the data values fall. All right. If you need any more help, reach out to us. Good luck, everybody, and we'll talk to you all later. Take care now.